Don't save. We are actually on lesson 5-3 today, and our favorite color is blue still. Today's date is November 15th, which is really cool because last year 5-3 was also on November 15th. I'm looking at the notes from last year too. All right, so advanced power antiderivatives. So I need to take the antiderivative of this guy. Before I do that, though, what is our objective?
Find the antiderivative of complex functions that require rewriting before taking the antiderivative.
Exactly. So it's the same stuff that we did yesterday, but you need to rewrite it first. Cool. We're going to do use substitution and taxman. I know that you guys like taxman more, but there are going to be questions that have use substitution, which is the reason that I'm making you learn it. So first, rewrite this. This is going to be the integral of what?
16 to the power of 2x, right?
16 times, right?
Times 2x plus 1 over to the power of
Negative 5, and don't forget the little, this guy, this dx, yeah. All right, perfect. So that's the only additional step for that one. This one's going to have an additional step. That one's going to have an additional step. That's the combo. Let's try taxman. So what are the three things that we need for taxman?
We need
U, we need taxman, and U prime. So what is U?
the answer.
2x plus 1. What is taxman? 16. And what is U prime? 2. Therefore, I'm paying taxman what rate? 8. So let's rewrite. Now that I know what I'm paying taxman, 8 is going to go in for the spot of 16. So I'm going to have the integral 8 times quantity of 2x plus 1 to the power of negative 5 dx. And I guess I don't need to have. I realize that a lot of the time I can kind of zoom in here and it would really help us see. All right, now, what's the next step? All right, let's take it. How do I do that? Yep, so I'm going to rewrite all of this stuff, and then I'm going to add 1 to that power. So here we go. It's still going to be 8 times the quantity of 2x plus 1 to the power of what then? Negative 4, and then I do what? Divide by negative 4, and it's kind of going to simplify right there. We can see, are we done? We need to add c. Always remember your constant of integration. And then we can reduce and make this a little bit nicer. So we can say this reduces to the final answer of, someone shout it out, negative 2 times
2x plus 1 over plus c. You have to do what?
So yeah, let's simplify this a little bit better. So negative 2 definitely stays on the top, but this negative power, I know I don't do it always on the answer key, and I need to go back and redo some of those. But this should now, I want to always rewrite it with a positive power, just get used to being able to change forms.
Okay. So 2x plus 1 to the 4th.
Oh yeah, to the 4th. Cool, so there's our final answer. We can box it. It's interesting that the projector makes this color look black when it's supposed to be red.
It looks red.
Just,
It kind of looks red.
all right, so let's come over here. It looks more red on my computer, I suppose. Use substitution. What are the 2 things that I need to find? U and a little bit more formal.
Oh,
du dx, exactly. All right, so U is the same things. Stego.
Wait, is it u prime or just u?
So this is U prime, but another way of writing U prime is du dx.
Yeah, but the top one you just do u.
Just U. It's always you're always going to do U for both of them. Exactly. Yeah. Exactly. What is du dx? 2. All right. Next step. What are we doing?
Taxman.
Nope. We're not on taxman. We're doing use substitution. Look back at your notes from yesterday. You guys got this. Not exactly. We're solving for something. Get dx, yeah. So how am I going to do that?
You plug 4 to
There's no plugging in, no. Cross multiply. So I'm going to think of this as over 1. So du times 1 is just 1 du. So I can say 1 du, or just du, I guess, is even simpler. And then if I cross multiply the other direction, 2 times dx, I get 2 dx is equal to du. And then from there to get dx by itself,
So you divide by dx.
divide by 2, exactly. If I divide by 2 on both sides, divide by 2, then I get the final thing I'm looking for, which is dx. Dx is equal to 1/2 du, or du divided by 2. Either form is fine. All right, that was tricky, but we found 2 things that we can substitute out now. So go back and look at your original equation over here in the blue. We're looking at this original equation. What can we substitute out? The dx. So this dx is going to turn into a du, and then what else can we substitute? This 2x plus 1 is going to be u. So my new integral is going to be 16 u to the negative 5 times dx, which changed into 1/2 du. And I guess it would make more sense to change the colors now. Let's change that to black. What do I do next? I guess before I take the antiderivative. Precisely, yeah. So this should be the integral of 8u to the negative 5th du. Arrow, what am I going to do?
Is this where you plug in U? Is that later?
No, we're going to do something else before that.
Antiderivative.
Can you do that for us, Arrow?
We need 2u to the negative 2?
Negative 2u, yeah. So I'm going to write out the steps a little bit longer, but you have the correct answer. So it's 8u, arrow added, so it's negative 4, and then divided down by negative 4, and she already simplified this to negative 2. But you're still not correct because, what arrow?
C.
There it is, plus c. And again, that simplifies to, we're almost done, so I'll keep this in a different color. This is still negative 2u to the, actually, this should be negative 2 over u to the power 4 plus c. And Claire, our final answer, therefore, is?
Negative 2 divided by 2x plus 1 to the
2x plus 1 to the power of 4 plus c. And you should have gotten the same answer. If we zoom back out a little bit, yes, we do have the same answer. All right, let's try another one. And I want you to use, well, before I do that, I need to get a poll here. Taxman, fist of 5. I see 5, 5, 3. U substitution, fist of 5. 3, is that a 3? 3.5, 2. Okay, so U substitution is about 1 point lower than average. That means we need to practice U substitution a little bit more. Let's use U substitution for this next one. Only U substitution. Help me rewrite the form. This is now the integral of what?
Negative 10 to the power of 5x minus 7 to the power 1/2.
Perfect. We still have that d of x, so we're going to copy that down as well. Okay, we're going with U substitution. If it's a minimum day, so I would like to do both U substitution and Taxman, but let's go ahead and label what we're doing. We're going to use U substitution. First step, go. Which is? And still with U, stego, therefore du dx is? Geo, what do we do next? Cross multiply. And this is where we can start picking up the pace a little bit. So you can cross multiply and then solve at the same time, and you'll know that your dx is going to be equal to what?
Du over 5.
There it is, 1/5 du or du over 5. Good job, yeah. Are we all comfortable skipping that many steps? Perfect, I'm going to keep skipping those steps in the future then. Next step, Claire.
Then we're going to have to plug in. So it'd be negative 10u to the 1/2 du over 5.
Perfect. Geo, simplify.
It's 5.
Careful. 10 divided by 5.
10 oh, 2
2.
u to the negative 1/2
Perfect. Yep. And from there, Stego, we are going to Can you do that for us, please? Careful. So I'm going to do 1/2 plus 1.
3/2.
Yep. So 3/2. And then do what? So if I divide by 3/2, it's the same thing as multiplying by 2/3, exactly. So you can just write the 2/3 over here or to the left, it doesn't really matter. So 2/3. Hold on, we missed a step up here. There it is, yeah. Plus C. So I have negative 4/3.
Wait, don't you flip it though? Oh, you did flip it.
A good catch, Geo. Yeah. U to the 3/2 plus C, and arrow finishes off.
So we plug in u, so it's negative 4/3 times 5x plus 7.
5x minus 7.
Minus 7? Yeah, minus 7. To 3/2 plus 7.
And let's simplify this one more step to make that into a radical again, just practicing going back and forth between the terms because it's great. I mean, this is the answer, and if it's a free response question, which it won't be, then that's great. But most times it's going to be multiple choice, and they love just making you turn it back into a radical. So
The square root of 5x minus 7 cubed, right?
it is, yep. So negative 4/3 out front, and then you can say 5x minus 7. I'm going to take that to the power of 3 still. That's where that 3 came from. But this divided by 2, that's going to make it a square root of that. I can write that a little bit better. And then don't forget your plus C. And I will make this note as well after we have that copied down. That's our final answer. I will make this note off to the side, just as a reminder. If I have something like u to the power of 3/2, that is equal to two different things. It's equal to u to the power of 3 square rooted, or it's equal to first taking the square root of u and then all of that to the power of 3. These are all the same form. Make sure that you know the square root can go, or the power of 3 can go on the inside or the outside of the square root. Both of them are fine. Usually this one is more typical, but that doesn't mean that this one is any less correct. All right. You guys make the call. Do you think it's better for you to do u substitution or taxman in this last one?
U substitution.
All right, let's do it. So first we're going to rewrite the form. This is the same thing as the integral of what? Try to do both of those two rules that we just did at the same time. We have a bit of practice because we've rewritten these forms before.
So it's x parentheses 3x squared plus 5. 1
Careful.
negative 1.
Negative 1/2. Perfect. So we're using u substitution, so let's label the method that we're using. And I'm always trying to use the left-hand side just in case you want to go back in your notes and study some more and try using taxman on the right-hand side. We're using u substitution. Sego, what are the two things we need to find? And du dx. Perfect. Geo, what's u?
3x squared plus 5.
And therefore du dx, Geo is?
Equals to dx. Oh, sorry.
Perfect. Stego, can you solve for, or can you do the next step all in one step instead of two steps?
That dx equals
1/6 d. We already have the dx. Yeah, du. Perfect.
Wait, what happened to the x and the 6?
Oh, yeah. So, like that. So make sure that it feels like you're paying tax at a variable rate, right? Hopefully that doesn't happen. And you'll see if it does or does not happen, because if you are still left with an x, you'll have a multivariable calculus problem, which will be difficult. Anyway, let's make the substitution now. So this was my original equation. Arrow, do you want to do it for us?
integral x times u to the negative 1/2 times 1/6x times u.
There it is. I'll zoom in again. All right. So you know if this problem is working if the x's cancel out. Do they, Claire?
Yes.
Yeah. These x's are on the top, one's on the bottom. So Claire, can you simplify this for us, please?
That turns into 1/6 u to the negative 1/2 du. Should I do the antiderivative?
Yes, please.
The antiderivative is 1/3 u to the 1/2 plus c.
Oh, you did it all in one step. I'm going to do it in two steps because are we quite there where we can see what's going to happen already with this and divide down and flip it?
It's going to be a positive, and you bring the positive down and flip it, so it's going to be 2/6 is going to be 1/3.
Okay, I think we're there. Stego, do you see why it's 1/3? Oh, nice. Okay, I like skipping steps as long as we are all on the same page on what's happening. This is now 1/3 u to the power of 1/2. Don't forget plus c. Perfect. And next step after here. Yep. So what is that, Claire?
It would be 3x squared plus 5 to the 1/2 plus c. But then simplify that, and you get the square root of 3x squared plus 5 over 3 plus.
So because the square
I have it.
the exponent is right, is a positive 1/2, the square root you put on top, right?
Yes. If it was a negative 1/2, then you'd bring it back to the bottom. Yeah, cool. Questions? Can you give me a fist of 5 again on use substitution? 4, 4, 5, and 3. We went up. All right, cool. That concludes the notes.
Can I go to the restroom?
You may indeed.